Hello students, let us discuss a text problem in the chapter Haloalkanes and Haloarenes. It is one of the textbook exercise question number 14. The question is, write the structures of the major organic product in each of the following reactions. Here, some incomplete reactions are given. We need to find out the major product of each reaction and we need to write the structure of each product. Let us do one by one. So these are the questions, that is incompleted equations given. Let us do the first one. The first equation is given in this way. First of all, when an equation is given to you, you have to identify the equation, that is the reactant are of which type. Here the reactant, this reactant is actually a haloalkane plus NaI. So we know that when haloalkane, that is Rx, in our reaction we wrote as Rx, when it is reacted with the NaI. So at the time halogen exchange reaction takes place. That means the halogen to halogen will be exchanges. So the product formed will be R. In the place of X, it will be I. So this is a halogen exchange reaction which we have discussed. And here, according to the question, R is this group. That is alkyl group CH3CH2 CH2, that is a propyl group. So once you have learned the general equation, whatever the question comes here, just write the R from the question and the answer is ready. So your answer is Ri, that means CH3 CH2 CH2I. So let us check the answer. This is a reaction which is called as Finkelstein reaction. It's one of the named reaction. So its answer is here. So you can check, you will be getting the answer. That is CH3CH2CH2I. That is idopropane. And this reaction is called as Finkelstein reaction. Let us discuss second problem. Here the equation is given. Incomplete equation is given. First of all, identify the type of reactant here. This is actually a haloalkane. And when you check the structure, it is a 3-degree haloalkane plus KOH in the presence of ethanol. Since this reaction we have not discussed yet, so we'll be discussing later on. Second problem, answer is here, that we'll be discussing later on. Question number 3rd in this, that is complete the equation which is given here. First of all, identify the type of reactant here. Here this is a haloalkane plus NaOH in the presence of water. So in the presence of water means NaOH is aqueous. So what is given to us? Aqueous NaOH is given to us. And we know that for an haloalkane, that is we represent by Rx plus aqueous NaOH. So this we have learned the equation, that is aqueous NaOH plus Rx, that is a nucleophilic substitution reaction. So in this reaction, X is substituted by the nucleophile, that is OH. So what will be the product here? The product will be ROH. So that is formation of alcohol. So what is R here? R is whatever given here, that is an R. So in the place of Br, we have to keep OH. So the product will be very easily you can generate. In the place of Br, you have to keep OH. So your answer is ready. That is CH3CH in brackets OH CH2 CH3. So there is a formation of alcohol by a reaction, that is a nucleophilic substitution reaction. Let us check the answer for this. So you are getting the answer. that is butane 2-ol, because in the reactant Br is on the second carbon, that is 2-bromobutane. So when we are treating with the aqueous NaOH, we are getting that is butane 2-ol. So formation of alcohol from haloalkane. Next reaction. Here one reactant is an haloalkane. So you can find this is a haloalkane plus KCN, and the condition is given aqueous ethanol. So as we have learned, KCN, Cn is an ligand, it's a nucleophile. So it is also a nucleophilic substitution reaction. That means in the place of Br, Cn will come. So we'll get a product, that is CH3, CH2. In the place of Br, there will be Cn. So this is also a nucleophilic substitution reaction, as we have learned this equation in the terms of R. So we are getting the product RCN, where R is the ethyl group. So our product will be CH3CH2CN. So we can check the answer here. So our answer is CH3CH2CN. This is also a nucleophilic substitution reaction. The next is C6H5ONa plus C2H5Cl. First of all, identify the reactant. This one is a haloalkane, and this one is in the place what we have learnt in general equation, RONA. It is just like RONA, but here R, instead of alkyl group, it is a C6H5. So the reaction will be in the same way how we have done in the general equation, that is RONA plus RX. Our RX is this one, and this one is our RONA. So in this, how we are making the product? Na and one X is removed. So we are getting the product, that is ROR. So we will be getting ether by this method. So same thing will be applying here. So what is our R here? Our R is C6H5 and the other R is C2H5. So that we can represent as R dash, because both are not similar one here. Therefore I am representing as R and R dash. So let us check our answer here. So our answer will be C6H5O C2H5. So here you can check your answer, that is C6H5O C2H5, and NaCl is the side product which is formed here. Next problem. First of all, identify the reactant. What is this one? Can we call it as a haloalkane? No, because there is no halogen here. There is a functional group OH, that is alcoholic group is present in this. So that means it is an alcohol plus SOCl2. So as we have learned that alcohol plus SOCl2, that means in the place of OH we have to keep Cl. So when we make the product, we'll be getting CH3, CH2, CH2. As it is what it is given here, the alkyl group CH3, CH2, CH2, and in the place of OH we are writing Cl. So that is a formation of haloalkane. That means we have learnt the preparation of haloalkane from alcohol. That is reaction with SOCl2. And here the side products are formed. These are SO2 and HCl. So you get this product here, that is 1-chloropropane. This is the most suitable method of preparation of haloalkane, because during this preparation the two side the subparticles, or we can say the side products which is formed, these are SO2 and HCl. Both are gases in state, so we can easily get the 1-chloropropane by this method. The next reaction, first of all identify the reactant. What is this one? This one is an alkene plus HBr in the presence of peroxide. So Just remember our general equation, what we have learned, alkene plus HBr. If there is a peroxide, so we have to use anti-Markovnikov rule. We have to use anti-Markovnikov rule. So according to this rule, the negative part will attach to that carbon which have more number of hydrogen, because our focusing carbon are these two carbons. So we'll be getting the product like this. So we can check that the Br is attached on that terminal carbon and H is attached, that is H is attached on this carbon and Br is attached on this carbon. So we get this product. That is using of anti-Markovnikov rule. Why we are using anti-Markovnikov rule? Because of the presence of peroxide which is given in the problem. The next, here also, in this problem also, it is an alkene plus HBr. But here peroxide is not given, therefore we have to use the rule, that is Markovnikov rule we have to use. So according to this, the negative part get attached to that carbon which have less number of hydrogen. So when you check these two carbon, this is our focusing carbon because double bonded carbon. So in this, which carbon have less number of hydrogen? Definitely this one. So Br will attach to on this carbon and H will attach on this carbon. So we get the product by the attachment of H and Br. We get this product, that is 2-bromo-2-methyl butane. You can check the position of Br. It is on the second carbon, so 2-bromo, and on the second carbon there is methyl group also, so 2-methyl butane. So all of you try these type of questions. So once you have learned the general equation, make the use of general equation and solve the problem. Only you need to check the R, whatever alkyl group is given in the problem, you have to substitute that alkyl group and do the problem. So all of you learn the general equation and try to apply the general equation in the given problem. Thank you everyone.